So the next, we'll be going through some binary operators and comparisons. We'll be rocking this, science. All right, so let's head back to our Jupyter Notebook. As we can see, basically Python supports all these kind of binary operators, and then we have these binary comparisons. All right, so here, and then we're going through them all together. Okay, so basically Python supports all the 6 kind of binary operators. The first one is the plus sign. We're gonna add A and B together, and then we have a subtraction here where we subtract B from A, and we have a multiple sign. We multiply A by B, and we have a division, and we divide A by B. And noticing here, we have a double division, or we call it a floor divide. So it will drop any fractional remainder. We'll go through that for example. Don't worry about it. But so far, you guys have to remember that this is like the floor division, and this is our usual or ordinary division. And this one means the power sign means we raise A to the power of B. Okay, so our first example will be our subtraction. And if we're going to subtract 7 from 5, we're just going to write here. So noticing that there's no semicolons needed, we just, read this as a single line of code. And then we execute it, and we got it, -2. All right? And then this next example, we're going to go through the summation sign, and which is this guy here, and we yell the example. The next one, we're going to go through the multiply sign. So we're going to multiply 3.5 by 4.98, and you can verify this result using your calculator. So noticing that there are different kind of divisions. So our first one will be the single division, which is our normal division, which give us the results here, 2.25. But this here, double division, which is also called floor division, give us only the integer part. So it will drop any fractional parts. So 0.25, 0.25 is dropped in here. And then our next example will be the power sign. So we raise 2 to the power of 3, which is going to be 8. So far, so forth, we have gone through 6 examples of all those different binary operators. So I want you guys to pay extra attention on this. So first is our usual division, and the second is our integer division, or just floor division. It just drops any fractional remainder, and it keeps only the integer part. And next, we're gonna go through some binary operations, or operators. It has these 6 kind of operators. So the first one is AND. So this guy here, A and B, will give us a true results if both A and B are true. And for integers, they take the bitwise AND. And then this sign here is true if either A or B is true. So if one of the A and B, or both A and B are true, then this A or B will give us a true results. And this guy here is the exclusive OR. So it is true if A or B is true, but not both. Okay, so if both A and B are true, they will give us false results. And then this sign here tests if A is equals to B. And this guy here tests us if A is not equal to B. And then this is here for less or greater than, and this is less than. So if A is less or equal to B, versus if A is less than B. And this goes the same here. If A is greater than B, then this one will give us a true result. And if A is greater or equal than B, then this will give us the true results. Okay, so let's jump into some examples. So we just gonna assign A is equal to 1 and B is equal to 0. So it is also worth to mention that, so in any programming languages other than Python, it's gonna be applying the same rule, which means that 1 stands for true and 0 stands for false. And so here we're gonna, first example is the end. So A and B is 0, which is false. Since A is true, B is false, so A and B is false, right? So remember, this guy here gives us the true results only if both A and B are true. Versus this guy here, A or B, give us the true results because one of the operators, A and B, is true, or both of them are true. So in this case, A is true, so it gives us a true result, which is 1. Okay, and this one here is exclusive OR. So since A and B are not be true at the same time, so it will give us the true results. So say from here, so for Booleans, true if A or B is true, so only one of them is true, this guy will give us the true results. If both of them are true, then this will give us a false results. And next, we're gonna go for the comparison. So this tests if 3 is equal to 4. So obviously 3 is not equal to 4, right? So it gives us a false results. However, if you're gonna test if 3 is not equal than 4, then it will give us true, because this one here is not equal. So 3 is not equal to 4. So this is true. Remember, this guy here is true if A is not equal, where this is equal. Okay. And next, we're going to test some comparisons. So it is true that 3 is smaller or equal to 3. So that's why this is true. But however, if we want to test if 3 is smaller than 3, then this one is false because 3 is equal to 3, right? So this one is false. And it is really interesting. Another, characteristics of Python is that if we want to check if two references refer to the same objects, so remember, everything you made in Python is an object, right? So these are object, these is object, these are different objects. So we can use the is keyword. So, so A is B. This one will give us true if A and B reference the same Python object, versus is not is true if A and B are reference to different Python objects. So say, for example, if we're going to assign 1 to 3 to A, so this give us a list, which we're going to go through later for more complex data structures in Python. So this guy here assigned to A. So this is an object, and then A is referred to this object, and then we also assign B to A, A to B, and then so B is referenced to A. Okay, so in this one here uses a function called list. It always creates a new Python list, so we can be sure that C is different from A. So right here. So we just created 3 different objects, and we're going to test using the keyword is. So right now here, A is B. It gives us a true result because B and A are referred to the same objects. Versus A is not C is also true because this one, the list function here, creates a new Python list. So that's why we can show that C is different from A. So C and A are referring to different objects, so that's why it's not give us a true result. If you're gonna say A is C, then you're gonna go for a false result. It's also it's also worth mentioning that is this keyword here is not the same function as the equal sign operator. So if we're gonna say if A equals to C, this will give us the true results because A and C holding the same values of the object. So remember here, every object has associated type and its value. So the equal sign here only compares the data or the value of the objects. All right, so we're just going to remember it. And then another very common use of is and is not is to check if a variable is none. So since there's only one instance of none. So none is a special form of Python objects, which means that there's nothing there. So if we just assign A is equal to none and A is none, it's going to be true. So these are some like very tricky Python programming like concepts. So just want you guys to have some like brief understanding of it, and we'll go through and talk about it later in the later lectures. So just to thumb up, for this small part, we go through some binary operators. We have 6 here, and then I want you guys to pay more attention to our ordinary or usual division, which will give us the exact results of A divided by B. And versus this one, we have a double slash here. It's an integer division or a full division, which only give us the integer part of the results, and it will drop any fractional reminder. And then these guys here are our binary operations or comparisons. So basically we just want to say this equal sign here compares if A is equal to B in the data, like in a data format or in the value. So it tests if A has the same value of B. And then this guy here will test A, it is not equal to B, which just means that A and B holds the different values. Okay, and then so this guy here, we don't need to worry about it too much. Just some tricks so that you guys can, if you have an interest in it, you can just read through it. But so on for now, you don't even have